Introduction. Our project will focus on the air pollution of our planet. As we know, it's a very important and necessary problem to solve as soon as possible. The CSG we choose is 13 Climate Action. Since it's related to the problem we will be investigating, we are currently faced with the problem of air pollution that affects both people and the environment in which we live. Our main objective is to find a solution to the problem through a prototype affiliated with CSG13 Climate Action that purifies the air and that it can fulfill its function.
Theoretical framework. We will delve into the issue of pollution, trying to solve it through an artificial tree that is a prototype of filtration of polluted air that passes through an algae filter. 1. Air pollution. It is the excessive presence of gases such as carbon dioxide, methane, and nitrogen and sulfur oxides, which generate an imbalance in the atmosphere and affect the development of plants, animals, and the health of humans. 2. Causes. They are the generation and mismanagement of garbage, the dumping of chemicals in water sources, the use of fossil fuels, and extraction of minerals and metals, and the use of pesticides in crops. 3. Consequences. We find global warming, unhealthy water, soil erosion, loss of biodiversity, habitat destruction, and respiratory diseases in living beings. 4. Our BioUrban is a cutting-edge technology that uses microalgae to capture pollutants from the air, contributing to the creation of cleaner and more sustainable cities.
High pollution lives on busy avenues in areas where vehicular traffic produces high levels of particulate matter. An artificial tree could absorb and filter some of these pollution.
Lack of green space in cities. When planting real trees isn't possible, artificial trees can be installed in small spaces to improve air quality.
Poor air quality at transport terminals. Transportation hubs often concrete emissions. An artificial tree could function as a local air filtration station.
Pollution generated by industrial areas. Industries that release toxic compounds could reduce the environmental impact by implementing filtration systems.
Urban heat islands worsened by poor air quality. Artificial filtering trees can reduce the concentration of pollutants that exacerbate the effects of heat in urban areas.
Conclusion. The proposed solution is photosynthetic organisms in a design that, without photosynthesis, has the potential to capture pollutants such as carbon dioxide and transform them into oxygen, emulating the providing capacity of natural trees. Sunlight and temperature were identified as a critical factor for the functionality and longevity of algae. The advantage of this approach lies in its low-cost, economical maintenance. Algae reproduce on their own under proper conditions, and the use of solar energy, offering a sustainable and energy-efficient alternative to improve air quality in the home.
The annexes present additional information and visual support for the development of the BioUrban prototype. The first section shows the prototype budget, which details the materials and the cost required for each construction. The total cost is 375 pesos, including dogwood and container, recycled cardboard, paint and brushes, and wooden sticks. This budget demonstrates that the prototype is designed to be low cost and accessible using recycled and affordable materials. The second section explains the functionality of the prototype. It describes how the system captures air pollutants through the methanization of microalgae. The pollution captured in this process is later converted into clean energy, making the prototype not only an air purifier but also a sustainable energy solution. The third section presents the budget for the exhibition model, which is a simplified version of the prototype made for display purpose. The materials used include a cylindrical container, cardboard, foam sheets, and leather sheet paper, with an estimated total cost of 95 pesos. This model is meant to clearly communicate the design and idea behind the project in a visual way. Finally, in the last section highlights the main benefit of the prototype. It emphasizes that the system improves indoor air quality by reducing pollutants, which contributes to better health, well-being, and overall quality of life for users.